Functions questions. Everybody loves functions, right? What we need to do here is work out what f does to the input and then see what we get as an output. So f takes x, and if you put x into the function f, you get x over x minus 1 out. So if you put 3 in, we're going to get 3 over 3 minus 1 out, which is 3 over 2, which is 1.5. And if we put minus 3 in, we're going to get minus 3 over minus 3 minus 1, which becomes negative 3 over negative 4, so we get 0.75, 3/4, whatever you want to write. It says state which values of x must be excluded from the domain of f. Okay, lots of people don't like this statement. Excluded from the domain of f. Now, if you're going to exclude things from the domain, that means that you can't put those numbers into the function. So how is it that you can't put numbers into a function? Well, you've got to remember the two things you can't do. You can't square root a negative number, at least not for GCSE. And you can't divide by 0. So is there any square rooting involved in this? No. But is there a possibility, is there some division going on? Yes. So is there a way in which we would end up dividing by 0? Well, what we're dividing by is what's on the bottom of f of x, which is x minus 1. So if that is equal to 0, that x minus 1 is equal to 0, then we've got a problem. So if x minus 1 equals 0, then we're going to have an issue. We won't be able to do the function, therefore, because we'd have to divide by 0. Therefore, when x is 1, we have a problem. And the way we would write that is we'd say x equals 1, not, because x is not allowed to be 1. Now, f of x. If we're going to work out f of x, we need to, first of all, work out f of x, and then, so we apply the function f to x, and then we apply the function f to the result of that. So whenever you see a compound function, it's good to put in some square brackets, and that's really not going to be very legible. I've taken f of x, and I've put some square brackets here because we're going to do f of x, and then we're going to do the f of that. So f of x obviously takes whatever you put in, and gives you x over x minus 1. Now, if we then take this result and put that into f of x, what do we get? That's what the question's asking. So now we need to look at what happens here. F takes whatever you put in, puts it on top of a fraction, puts something on the bottom where it's the same thing minus 1. So if we put this into a fraction, we're going to get the same thing on top. And on the bottom of the fraction, we're going to get that minus 1. I hope people understand how that works. If I did f of a fish, that would be fish over fish minus 1. If I did f of smiley, that would give me smiley over smiley minus 1. So if I've already done f of x, and I've got x over x minus 1, if I do f of that, I'm going to get x over x minus 1 over x over x minus 1 minus 1. Now, we're going to deal with some rather nasty fraction simplification if we're going to reduce this down to something less complicated. How do we do that? Well, there's a couple of tricks you need to know. First of all, this expression on the bottom has two terms in it. So if we were going to simplify this, we would have to write x over x minus 1 minus 1 as being a single fraction over a common denominator. So because 1 is a whole number, if you turn it into a fraction, you could write it as 1 over 1, and then multiply top and bottom by x minus 1. So x over x minus 1 minus 1 is the same as x over x minus 1 minus x minus 1 over x minus 1. I hope you're happy with that. So this is the same thing written out. X minus 1 is going to be x take away x plus 1. So that simplifies to that, which simplifies to x minus x cancels out, and minus 1 becomes 1, so you get 1 over x minus 1. So that bottom fraction simplifies to 1 over x minus 1. So then you've got x over x minus 1 over 1 over x minus 1, which simplifies down to just x. I don't feel like I've explained that fully, so please ask me if you're not sure about this one. The final thing to note is that if the function takes an input x and gives you something out, and then if you apply that function to what you get out, and you get the same thing as you started, then you know that the function is self-inverting. Means if I put in 7 and I get actually 7's a bad choice. Let's say I put in 2. No, 2's going to give me 2 out again. Okay, let's say I put in 3, right? Because that's the first example. If I put in 3, then as we know from the first result, I get 1.5 out. If I put 1.5 into the function, I'll get 3 back out. So I'm saying a lot to try and explain this. Basically, you take a function, you get an output. If you apply the same function to the output and you get the thing that you started with, then it's self-inverting. So if you end up with x, when you apply the function twice, it's self-inverting. This does seem to come up a lot, so just be aware of it.